So yes, Danny, that is correct. A controls the stretch, makes the peaks taller and the valleys lower, and it also controls the flip if it's negative. Luke, what does B control?
I don't know exactly what it's called, but like it makes it like more waves or less waves.
Yes, Luke's doing this.
Yeah,
Yes. It controls the period. And it's maybe the weirdest one because the period is 2 pi over b. That's what we did Friday. And so the bigger b gets, the squinchier, the shorter the wavelength. If b is really small, it stretches it out. So b controls wavelength or period. Gregory, now we're down to the easy two, I think. What does C control? The left and right shift. So the whole graph shifted left or right. And Brandon, what does D control? The up and down shift. So the whole graph moves down or up depending on what D is. Again, the test is we'll give you some equations and ask you to graph them. We'll give you some graphs and ask you to give the equation. We'll give you some A, B, C, D and ask you to write the equation. And so there's just a whole bunch of different ways to work with that formula. I guess the other thing we need to be careful about is sine and cosine and his friends have a period of 2 pi. What about tangent and cotangent? What's their period? If it's not adjusted anyway. Pi. So as part of review, before we jump to today's lesson, let's do number 9, because that will review all of that A, B, C, D stuff. In fact, since we know it so well, let's just pull 5 popsicle sticks and see where we land. Okay, Toby, number 9. Does it have a vertical reflection? Yours is just a yes or no answer.
Yes.
Yes. Why does it have a vertical reflection?
There's a negative.
Because of the minus sign. Cecilia, what's the amplitude?
3.
Good. 3, not negative 3. Amplitude is just the height above the midline. JD, the horizontal shift?
Right, pi over 2.
Good. Right, pi over 2. Austin, the vertical shift? Up 2. And Landry, the period is pi because 2 pi over b is pi. Now we have to figure out how to put all of that information on the graph. The shifts usually go first. So right pi over 2 and up 2. Let's see. Up 2, but my amplitude is 3. Remember, so you have to kind of look at multiple things at once here. So what's the highest this graph is going to go? 5. Good. So I need to sort of plan ahead. If I want 5 to be the top, then pick something reasonable for where 2 goes. And then a horizontal shift of pi over 2. The period is pi, so I could put pi over 2 a pretty good distance away. And then the next one would be pi, and then 3 pi over 2. And so there's my one period between pi over 2 and 3 pi over 2. Because I'm going to start at pi over 2, and I'm going to go pi away. And then I like to put my new origin on there, a little plus sign. And now I can base everything off of that picture, or off of that origin, and I don't have to worry about my shifts anymore. Okay, graph of cosine. Do the little baby parent function here. That's what cosine looks like. So normally starts at a max. what is this graph going to start at? Okay, 5 will be the max of this graph, so that is true. But why doesn't this graph start at 5? Because it's been flipped.
Oh, yeah.
So I am going to start at an extreme, but not the top extreme. I've been flipped, so I'm going to start down 3. Which would put me at -1. Right on top of my pi over 2 label there. Which means my start over point is another A point. The maxes will, when now they're the bins because of the flip thing, will be pi away at 3 pi over 2. My minimum, or at least my usual minimum, has been flipped to be a maximum. So halfway in between the two A points will be a maximum. And then lastly, in between the A's and the B's, in between the maxes and the mins, are the zeros, but be careful, we don't really mean 0, we mean kind of the new 0, which if you need to put a midline on there, that's nothing wrong with that. And again, don't make a mountain here, make a my cosine wave. Sketch at least 2 periods. We almost always want you to graph 2 periods. No?
I'm just about to ask that. How much do you graph?
Yeah. Almost always it's going to say 2 periods. And so that leaves it open to you, depending on where the graph is. You might want to graph the next period to the right or the next period to the left. For this one, obviously, my space is going to work better for the left. So I want to get the start over point down. So if I go pi away from pi over 2, but now I need to go backwards, where's that going to land at? What's my next start over point? What's that? It doesn't have to be negative. Well, I didn't hear what you said. It is going to be negative. It's going to be negative pi over 2 because it needs to be 1 pi away. So my starting point is down 1. Halfway in between is at the maximum. And then halfway in between there, we're at the zeros. So there's 2 cycles of that cosine graph. And then that last question we already answered. The maximum value would be 5. To me, that's the heart of the whole unit right there. If you can do 8, 9, and 10, then everything else is questions about it or asking things differently. But if you understand 8, 9, and 10, you're fine. So some of the tests will be like these property questions, like the first 1 through 7. But some will definitely be you have to graph everything. But we will ask you, we're not just going to say, here, graph it, and not give you anything. We're going to say graph it and ask you all those questions. So we kind of provide the framework or the outline of making sure you consider everything. All right, let's look at notes for today. It's only 1 page. We don't have notes tomorrow. Like this is a good notes day. I mean, if you got to have a notes day, it might as well be a short notes day over stuff that, in theory, we kind of already know. So, notes 4. This is a backwards day. So instead of me giving you the equation, and you, let's see, that was Friday. Equation to graph. Today is going to be properties to an equation. Like I'll give you the properties, you give me the equation. And then Wednesday will be completely backwards. I'll give you the graph and you'll write the equation. So that's what I'm trying to say by it's, if you know how to take the equation or to get the graph from the equation, the rest of this is just practice seeing if you can drive backwards. But you learn how to drive, you gotta learn how to drive in reverse. That's what we're doing today. All right, number 1. State an equation of the sine curve. So we know we're doing sine. With a period of 3 pi, an amplitude of 3, a right phase shift of pi over 6, and a vertical translation down 2. That's a lot of pieces in there. Maybe we should start by putting that generic equation up there. Sine, so I know it's sine. Period of 3 pi, that's probably the hardest one to deal with because our period is normally 2 pi. So I've got to figure out what b is. This is what we just did on the last worksheet. So cross multiply, or maybe some of you can just kind of see what happens when you cross multiply and divide. The pi's cancel, and b is 2/3. The rest, I think, is fairly straightforward. So let's see how straightforward it is. Pick on some people here. Angel, the amplitude is 3, so where does that go in the equation? Yep, that's what A is. We'll put a 3 out there. Noah, we have a right phase shift of pi over 6. So what do I do with that in terms of the equation? Good. X minus pi over 6. And Evan, we have a vertical shift of down 2. So where does that go, or how do I make that show up in the equation?
Just do -2, like all the way to the right.
Good, -2 at the end. So the period takes a little bit of work. Everything else is pretty much plug it straight in. All right, I want you to try number 2. So I'm going to press pause. You try number 2. So 7 equals 2 pi over b. So yeah, move things around a little bit. And b equals 2 pi over 7. Joseph, how about the amplitude of 5? What is that? Where does that go in the equation? That's A. Good. A phase shift of 2, left 2. Austin, how do I go left 2? Good, x plus 2. And then Jake, how do I go down 3? -3 at the end. So I think today is pretty easy. Like the period thing, that takes a little bit of work. Not much, but a little bit of work. The rest, if you know what A, B, C, and D are, you just put them in the right spot. All right, number 3, a word problem here. It gives us the equation, so hopefully we can figure this out. The number of hours of sunlight in San Diego can be modeled by a function h, where h is in hours, t is in days, t equals 1 corresponds to January 1st. So we got some sine wave with all these different changes to it. Let's first just see if this makes sense. There's a sine wave, and that does correspond with the hours of sunlight any particular city gets, right? Because like in the middle of summer, like that's summer equinox, is that what that's called? The highest point? And the lowest point is winter when you don't have much sunlight. Winter solstice or something like that. Winter. So yeah, you can model that with a sine and cosine. So let's see if this. What is the period of the model? Well, period is 2 pi over b. So 2 pi over 365. So that maybe looks complicated, but what happens to, what does that become? 365. And t is in days, so 365 days. Does that make sense for this situation? Does 365 days sound like a familiar type value? Yeah, that's 1 year. So over the course of a year, we get 1 cycle of this sine wave. Part B, what is the maximum number of hours of daylight in San Diego according to this model? So what's the maximum of that going to be? Can you figure that out? So 12 is that's the D, that's sort of the midline for this graph. So that would be more like the average. How far above 12 does it go? .4. So 12 is the midline, but it goes 2.4 above that. So the maximum hours is 14.4. How about the minimum hours? It'd be the same type thing. 12, but then minus 2.4 would be 9.6 hours. What is the average number of hours in San Diego over the course of a year? 12, although that question is not asked. The average number of hours, doesn't that need to say of sunlight? The average number of hours per day would be 24, but I don't think that's what they're asking. Use a graphing calculator, we may not do that, to find how many days it takes for the number of hours of daylight to exceed 12 hours per day. In which month does this occur? Okay, so you'd have to graph that and look at it, and we're not going to mess with that. So you want to keep it without a calculator. So today's assignment is worksheet 4. If you look at worksheet 4, it's a whole lot of what we just did. Write an equation, a little bit of word problem stuff. Well, you know what, it does say use a graphing calculator. So let's do the graphing calculator part. You know what, we'll do the graphing calculator part tomorrow, because tomorrow's pretty simple. So we'll worry about that tomorrow.